Lesson 2.2. Graph quadratic functions in general and intercept form. Intercept form is y equals a, x minus p, x minus q. And it's called intercept form because p and q are the x-intercepts. So here's a p and there's a q. Notice the axis of symmetry is halfway in between. So we'll take the average of p and q. In this case, p was -2, q was 2. If I add those together, I get 0. Divided by 2 is 0. See, the axis of symmetry is x equals 0 in this graph. And our vertex is the axis of symmetry for the x, and you have to just plug it in to find the y value. That's what this f of that means. It just means plug it in to get the y value. We also have general form. General form is this, and this is what you get if you take the standard form and the intercept form and you just multiply everything out and combine like terms. You just get this general form. The axis of symmetry is -b over 2a, and the vertex is that axis of symmetry, and then you plug it in to find the y value. So how do we graph a quadratic function? Well, first of all, you can find your axis of symmetry and the vertex. Really, you're looking for the vertex, but the axis of symmetry is fine because you're just going to make a table. So then you make a table of values, your axis of symmetry, or the vertex in the middle, plot the points, draw a nice parabola, which is the shape of the curve, either opening up or opening down. Let's graph this one. We have these two factors. That makes it intercept form. So as you can see, this would be like x minus a -2. So p is -2 and q is 3. So those are our x-intercepts, -2 and 3. The axis of symmetry is halfway in between, so we're going to add those together. Divide by 2, so it'll be -2 plus 3 over 2, which is 1/2. So our axis of symmetry is at 1/2. Let's go ahead and finish that and get our vertex. So our vertex is the axis of symmetry, comma, what you get when you plug that in. So that would be 1/2. Oh wait, let's just plug this in. So -2, 1/2 plus 2, 1/2 minus 3. And you probably will want to use your calculator to help figure that one out. You get -25 over 2. Well, I don't know. What is -25 over 2? Well, that's 12.5. Now, is 12.5, -12.5 going to fit on my graph? No, it only goes to 6. So, what do we want to count by to make this fit? Well, we could count by, if I counted by 2s, that would get me to 12. Then I just go a little bit over, maybe. And the y's, I'm just going to leave it counting by 1s, so I'll have to mark that. Whenever you go by something that's not 1s, you have to mark your scale. All right, so 1/2, -12.5 is going to be about there. So then we need to make a table. Let's see if that's good enough. All right, going to go over here, let's put in my new expression, negative 2x plus 2, x minus 3. Uh-oh, syntax error. I missed the last parenthesis. There we go. Let's look at the table. All right, negative 3 is negative 12. Negative 2 is 0. That's my x-intercept. Negative 1 is 8. 0 is 12. 1 is 12. Oh, sorry. 12, 2 is 8, 3 is 0. And I made a mistake typing in my intercept. It's actually a positive 25 over 12, so it's 12.5. If we want, we can look at the graph on the calculator. Woohoo! Let's draw our own. You can't just look at the calculator and draw your graph. You have to plot the points, so it goes to the correct points. Negative 3 is negative 12. Negative 2 is 0. Negative 1 is 8. 0 is 12. Then we have our vertex, which I had made a mistake on. It should be a positive 12.5. And then 1 is 12. 2 is 8. 3 is 0. 4 was negative 12. So here's a nice graph that takes up the entire graph like that. And try to smooth it out a little bit so it looks nice. Well, that's your graph. Let's graph x squared minus 2x minus 3. This is in general form. This is ax squared plus bx plus c. So we can see that a is a 1. A means the same thing it did in the others. It's going to open up. B is a negative 2 and a c is negative 3. The axis of symmetry is x equals negative b over 2a. So that's negative 2 over 2 times a, which is 1. So that comes out to be 1. So the vertex is 1. Oh, we have to plug that in. So we'll go ahead and plug in the 1. Get 1 minus 2 is negative 1, minus 3 is negative 4. So our vertex is 1 minus 4. So the rest of it is make a table. So let's bring the calculator back out. Let's put in our new equation. So we have x squared minus 2x minus 3. If you want, we can look at the graph, but that's not going to be useful for us because we have to actually plot the points. We're going to go to the table. My vertex was at 1, negative 4, so let's go smaller than that and bigger than that. So I want 3 on each side. So let's try this. Negative 2 is 5. Negative 1 is 0. 0 is negative 3. 1 is negative 4. That was our vertex. And then it is symmetric on the other side. Plot those points. Negative 2, 5. Negative 1, 0. 0, negative 3. 1, negative 4. 2, negative 3. 3, 0. And 4, 5. Draw a nice parabola. Let's go the other direction again. Let's start with the graph and get the equation, the function. So the first thing is in intercept form. If you know the x-intercepts, you're going to find the x-intercepts. And you need one other point. Put in the x-intercepts into your intercept form. If you know the vertex, you'd use vertex form. If you know the intercepts, the x-intercepts, use intercept form. The other point is x and y. Solve for a. Write your function. Right, the quadratic function whose x-intercepts are -3 and 7 and passes through 0 and 21. Now we are told these are x-intercepts, therefore that is p and that is q, and this point will be x and y. Since we know the x-intercepts, we will use intercept form. Plug in the p and the q. X minus a -3 can simplify to be x plus 3. And now we're going to plug in this other point for x and y. So y is 21, x is 0. Simplify, this will be a times -21. Divide, looks like a is -1. So now I know a, the p, and the q. Just take that and fill in the a. So it'll be -1 times x plus 3, x minus 7. Let's try one from the graph. From the graph, usually the vertex is nice, but I don't really know where that point is. But I do know the x-intercepts. So I know the x-intercepts are p, which is -4, and q, which is -1. So since I know the intercepts, let's use intercept form. Fill in the p and the q, so it'll be -4 for the p, -1 for the q. That can simplify because minus a minus is a plus, so it'll be x plus 4, x plus 1. But we need to know a, so we need to find some other point. That would make a good other point. 0, -2. That's the x and the y. So the y is -2, x is 0. Now it's just any point works. It doesn't have to be 0, comma something, but you have to know what it is exactly. This will be 4 times 1, so a times 4. So a appears to be -1/2. So now if I take that one there, that little equation, and fill in the a, so it will be y equals -1/2, x plus 4, x plus 1.